In this example, we have a right triangular area in which to build a play structure. The triangle has base 30 feet and height 20 feet, and this play structure side must be a rectangle, and I want to find the dimensions of the largest structure I can build. So again, this is very geometry based. Let's draw a picture. There's our overall area that we know is 30 feet by 20 feet. And we're building a rectangular play area inside. So it's going to look something like this. Now, what here am I allowed to change? Well, I'm allowed to change the length and width of this play area. So L and W here, L for the length, and W for the width. This is what I'm allowed to change. And I'm also trying to maximize the area. I want to build the largest structure possible. So I'm trying to maximize the area, which is L times W. Now we have to figure out, how do L and W relate to each other given this picture? So based on our labeling here, we know that this here is W. So this length here is 20 minus W. And since this is a right angle here, I know I have similar triangles. Relation tells me that 20 minus W over 20 part to full equals L over 30 part to full. Simplifying this out, I get that 20 minus W equals 2/3 L, or W equals 20 minus 2/3 L. I can plug in for W here. So if I do that, I get my area function, which is L times 20 minus 2/3 L, or 20L minus 2/3 L squared. And the interval here, well, L needs to be positive, and W also needs to be positive, which means L can't be more than 30. Also, those numbers make sense because I need the rectangle to fit inside this triangle, and so L can't be less than 0 or bigger than 30, otherwise it doesn't fit in the triangle. Now we can solve the calculus problem. The derivative is 20 minus 4/3 L. That always exists. When is it 0? Well, it's 0 when L equals 15. 15 times 4/3 is 20. I can list out my values. Well, if I plug in 0, my area is 0. If I plug in 30, my area is also 0, because then W is 0. If I plug in 15, I get 15 times 10, or 150. This is clearly the maximum. Now, what does the problem want? The problem wants the dimensions of the largest structure. The dimensions are L equals 15, and plugging that into W, W equals 10. And that's how you find the dimensions of the largest structure in this particular problem.